Task number 2, host discovery. Who is online? Let's start with the first question. Who is online? This task aims to find out how to use Nmap to discover the live hosts. Nmap uses various sophisticated ways to discover live hosts. Before we start, we should mention that Nmap uses multiple ways to specify its targets. One thing I want to mention over here is the fact that Nmap is a tool that you will use a lot, but almost like with any tool that you will use, the scripts or the entire command that you will use with Nmap, it will be pretty much the same. You will use pretty much the same switches with the Nmap, depending a bit on the specific case. It's pretty much the same with every tool, but I wanted to say this because it's great to have a note text file where you keep the commands, because you will custom them and you will almost always use them like that. IP range using, yeah, so basically here we can ask for IP ranges with hyphen. If you want to scan all the IP addresses from this IP to 1 to 10, you can write like this. So you write the first IP and then hyphen 10 at the end. IP subnetting using /. If you want to scan a subnet, you can express it as following. At the end, you can see /24. And this would be equivalent to basically 192.168.0.0-255. Host name. You can also specify your target by host name, meaning the URL. So here we have an example.tryhackme. Let's say you want to discover the online hosts on a network. Nmap offers the -sn option, that is ping scan. However, don't expect this to be limited like ping. Let's see this in action. Before we get started, we should note that throughout this room, we are either running Nmap as root or using sudo, because we don't want to restrict Nmap's ability with our account privileges. Running Nmap as a local non-root user would limit us to fundamental types of scans, such as ICMP echo, which we can do with ping, and TCP connect scans. We will revisit this at the end of this room. Scanning a local network. In this context, we use the term local to refer to the network we are directly connected to, such as Ethernet or Wi-Fi network. In the first demonstration, we will scan the Wi-Fi network with which we are connected. So we are connected to a Wi-Fi network, right? We are using the internet via Wi-Fi. What we want to do in this scenario is just to use Nmap to scan our local network. Our IP address is the following, and we are scanning the entire network. The Nmap -sn, and we've seen this over here, is the output are shown in the terminal, right? So here is the command, and Nmap starts scanning, and then this is basically the output. It's, of course, it's just the output is much longer, but for demonstration purposes, this is basically what you will see. Because we are scanning the local network where we are connected via Ethernet or Wi-Fi, we can look up the MAC addresses of the devices. You can actually see it neatly written. Perfect. Consequently, we can figure out the network card vendors, which is beneficial information, and it can help us guess the type of target devices. Yes, so basically a MAC address is split in two. The first part, this one, is the manufacturer's code, and the right part is a unique ID, right? Let's see. Address, code, explained. Let's see. Unique, all right, the function two parts. The first three parts identifies the manufacturer, and the last three are a unique serial number. So basically, this is a MAC address. Another MAC address is over here. If you split it, the first 6 symbols and letters actually is just numbers and letters, and the last 6 you get the first 6 are the manufacturer and last 6 are unique. This is for every device ever. The MAC address is basically unique to every device, meaning that if you have an iPhone, if you have 2 iPhones, they don't have this this MAC address, both of them. They have the manufacturer code, but the unique code is different for both of them. You can play with this, but let's leave it to this, because that concept is basically an advanced topic, right? Mac spoofing, you can just change the MAC address of a device to, if you want to reflect a device or something. All right. Consequently, we can figure out the network card vendor, which are beneficial information, and it can help guess our target device. When scanning a directly connected network, Nmap starts by sending ARP requests. When a device responds to the ARP request, Nmap labels it with host is up. Host is up. Host is up. Host is up, right? Scanning a remote network. Consider the case of a remote network. In this context, remote means that at least one router separates our system from this network. As a result, all our traffic to target systems must go through one or more routers. Unlike scanning a local network, we can send an ARP request to the target. Our system has the IP address the following and belongs to this entire network. In the terminal below, we scan the target network, basically the entire network, where there are 2 or more routers, basically hops. If you make a request, those routers will be hit, let's say. The traffic will go through them, or at least will go to them, because if you have a firewall, it can stop there. Separate our local system from the target host. So basically we have the same Nmap command with the same flag, and we have a different network. And then it started to scan, right? We see the results. Host is up, right? IPs. The Nmap output shows that 5 hosts are up. But how did Nmap discover this? To learn more, let's see some sample traffic generated by Nmap. In the screenshot below, we can see the responses from 2 hosts. Again, we are used with Wireshark, the best tool to just read captured traffic. We have 2 addresses, 2 IPs. The first one is live and responded to the ICMP echo ping request, and the second IP seems down. Nmap sent 2 ICMP echo requests, ping requests basically, 2 ICMP timestamp requests to TCP packet support 443 with the SYN flag set, and 2 TCP packets to port 80 with ECK flag set. The target didn't respond to any. We observe several ICMP destination unreachable packets from the following IP, which is the router IP. Over here we see that IP. The router IP, clearly destination unreachable. And here are the 2 requests from our host to the first IP here and the second one here, right? Internet protocol version. Yeah, basically here we see again the same breakthrough that we've seen in Wireshark Room. You can read it. I have it up and running. It is worth noting that we can have more control over how Nmap discovers a live host, such as PS port list, PI port list, Okay, so basically here we see extra flags for Nmap, uppercases PS, PA, and PU for TCP SYN, ACK, and UDP. Discovery via the given ports. However, this is beyond the scope of this room. As a final point, Nmap offers a list scan with the option -S and uppercase L. This can only list the targets to scan without actually scanning them. For example, Nmap and then the same flag with a network will list the 256 targets that will be scanned. This option helps confirm the targets before running the actual scan. As we mentioned earlier, -SN aims to discover the live host without attempting to discover the service running on them. This scan might be helpful if you want to discover the device on a network without causing much noise. So if you know that a device has a firewall, a router has a firewall, you basically use this. However, this won't tell us which services are running. If we want to learn more about the network services running on the live host, we need a more noisy types of scan, which we will explore in the next task. All right, we started the machine. Answer the questions below. What is the last IP address that will be scanned when you scan the target? Okay. Let's show the split view. Okay, cool. We are inside our machine, and then we say nmap. Sorry. And you can see over here, basically it's divided in categories, and you can see then for the related category, you can see flags. And you can just play with commands. At the bottom, you have examples already made. But you can also go like manual and map, and again, go through it. Let me see if I go like this. Help. Yeah, help is just to display the... I will show you help. See, like how to use help command. All right, let's do this question. Nmap and map sn. What is the last IP? 192.168.0.1.27. Let's see. If you press now enter after a scan was started, you can actually see the percentage where it is with the scan, like okay, so basically it's not here this is what I want, what I wanted to show you. Okay, it will be done in a second. Yeah, so basically we have to... Warning, unable to determine any DNS servers, reverse DNS is disabled. All right, no problem. We'll go with SL. Report 4. This is it. 192.168.0.31. Now, if you go again, nmap. Let's say a grep for SL. So we just used this command, right? Like we've seen over here. List scan SL. Simply list targets to scan. SN ping scan. Disable port scan. So basically, let me show you. If for instance we take an IP from here, and I will say ping this IP, it's doing nothing. right? Let's try another one. Let's try the last one. 031 is doing nothing. So this is basically, this is the command that we needed to use as uppercase L, because we don't need to use the ping command, right? Host is down. Packets transmitted 11, received 0. 100% packet lost. Cool.